This video clip is about homework 24 from our problem sets. And we started off with this bell work. It should have taken about 12 seconds to do. I gave 2 minutes to do it. You draw 3, and if you draw the arrow to the right like this, it's incorrect. You still have to circle the number. Do we color it in? Yes, we do, because it's greater than or equal to. So it includes the -3. And then we had 3 number lines. On the first one, you were to draw numbers that are greater than 1 or less than -3. So I'll put some numbers on the number line to do this. And we'll start with 1. Greater than 1 does not include the 1, so you leave it an open circle. Less than -3, it does not include -3, so we leave it an open circle. We go to the left because it's less than. An open circle is used when it is greater than or less than, but not when it's greater than or equal to. If it's included because it's equal to, then you color it in. So the next one, all numbers that are greater than -5 and less than or equal to, number 4. Notice it says or, but this is not an or situation. This is an and situation. It says greater than 5 and less than or equal to 4. The less than or equal to goes together. So greater than 5 means you leave an open circle. Less than or equal to means you leave it a closed circle. And both conditions have to be met because this is an and conditional. These are both conditional statements. The first one is an or statement. Notice they're going in opposite direction. And then you have an and situation where they're going in the opposite directions toward each other. The last question is a little bit more challenging. It says all numbers whose squares are greater than or equal to 1. So we'll draw 0 and 1 on here. Since it's got to be greater than or equal to 1, we'll circle the 1. And we'll color it in because it's or equal to, and everything to the right. And if this was your answer, this would be incorrect. Let's check some other numbers. 0 squared would be 0, that's not included. What is 1/2 squared? 1/2 squared, my intervention was that you underscore the base of the exponent. Here the base is in parentheses, so it's 1/2 times 1/2. That's the, and we're going to multiply by itself that many times. What is 1/2 times 1/2? That's going to give you 1/4. So that too is not greater than or equal to 1. And we can see that this is so far so good. But what about -1? 0 times 0 is still a no. It doesn't work. If you do a negative times a negative, it becomes a positive. And a negative times 1 times -1 is greater than or equal to 1, so it includes all the numbers to the left. Here we have this symbol. If should be in your notes somewhere. This is less than. This is the more than symbol. Greater than or less than. Is less than, is greater than. The next one is less than or equal to, is greater than or equal to. And that's what these symbols mean. I'd also like to point out the conditionals. A conditional statement means that you're going to have 2 of these less than or greater than or equal to symbols involved. And there's 2 fundamental types of conditional statements. One is an or conditional, which I've given you the example of in letter A here. And the other one is the and conditional. There are also 2 special cases that you want to remember, and those are the no solutions set and the infinite solutions set. So don't forget about those. In this question, we try to find the notation that goes along with the graph. So these are the same 3 questions I asked before, but what is the notation? For the first one, all numbers x that are greater than 1 or the numbers are less than -3. Now if you have an or situation, the words or are going to be part of the solution. Okay, here I'm talking about the compound inequalities. Compound inequalities, you have an or situation. You can also have an and situation. You can have no solutions or infinitely many solutions. And by that I really mean the set of real numbers. So there's the or, the and not to be confused when we say infinitely. No solutions, NS, or infinitely many solutions. So in this part B, all numbers that are greater than -5 and less than or equal to 4. So you have, this is an and situation where it's all written as one statement. There is no and letter words in there. You have 5 is greater than -5, x is greater than -5, x is less than or equal to 4. That's an and conditional. And the last one, numbers whose squares, so x squared, is greater than or equal to, I'm going to use a darker color here, greater than or equal to 1. So this was the primary learning for the day. Then we had some review of getting things over a common denominator. The common denominator between, in the red here, is going to be 20. And I can multiply anything by 1 and not change its value. My 1 here, in this case, is going to look like 4 over 4 because I want 20 in the denominator. And here it'll look like not 3 over 3. No, erase that. We're going to get 20 in the denominator here, I have to multiply by 5 over 5. And when you do 4 times 27, you get 108. All right, let's talk about fractions for just a second. If you have 2/3 and you have 3/3 and you add them, you get 5/6? No, you don't add the denominators. You get 5/3. 2/3 plus 3/3 is 5/3. So when you're adding, you don't add the denominators. You get a common denominator and then you add the numerators. If you were multiplying, you would multiply both the numerators and the denominators. But this is not 5/6. This is 5/3. So here, when I'm adding the 4 times 27, and to get 108 and 15y, those are not like terms, so you cannot combine them. I'm going to do 4 times 25 plus 2. So instead of doing 4 times 27 directly, I'm going to split this number up, which is what we've been doing in our number talks, and I'm going to put it together again. Well, I have 25 fours, and I also have 2 4s. So I can look at that. Well, 4 quarters is $1, and 4 times 2 is 8, so it's 108. In this second problem, our common denominator is 15, so we multiply the left side by 3 over 3. We multiply the 2/3 by 5 over 5, and we get 4 times 3m is 12m, and you have a minus. 5 times 2 is 10. And that's our final answer. The third problem, our common denominator, notice it's a little bit different here. Common denominator is 3. So we'll have to multiply 2 by 3 over 3. This is just a refresher on getting a common denominator. 6 minus x is over 3. Common denominator here is 12. Notice the 2 and the 4. 4 would be the least common denominator of those two, but between 3 and 4, it's 12. So to get 12 in the denominator of x over 2, I'm going to multiply by 6 over 6, by 4 over 4, by 3 over 3. And I'm going to pause this for just a minute. And I've sped up the video a little bit so I can talk a little faster. Here, when we multiply 3 times -3x, you get -9x, and your total is going to be 5x over 12. And we have some multi-step equation practice for a test that's coming up. Notice if it says negative and there's parentheses, that's the same as a -1. I'm advocating that we use the box or the area model in order to distribute. First thing you'll do when you see one of these is to distribute. And so we get 4 minus x minus 3 on the left-hand side of this equation. On the right, we'll also use the box or the area model. So you have a -5, and this is so that you don't drop your negative signs or put in extra signs where you're not supposed to. You can see very clearly -5 times 2 is going to be 10, -10x, -5 times 2x. And you have a -5 times a -3 is a plus 15. So on the right side we get 8 minus 10x plus 15. And in this scenario, when we have like terms, notice there's only one term with an x in it, but the others, 4 minus 3 is 1, so we have 1 minus x. You have an 8 and you have a 15. I'm underscoring the ones that are like terms that I can combine. I cannot add an x term with a non-x term. Here we want to get the small brother. The negative 10 is smaller than negative 1, so we're going to move it to the other side of the equation. And that's so that I don't have to divide by a negative number. It's not required, but just good practice. And so anything you do to the left side of the equation, you do to the right. Here we're adding 10x to both sides of the equation to do the inverse operation to get rid of that negative 10x. So when I combine it, I have 1, and I have my negative x and 10x combines to 9x. You have 23, and you have 0. Now I want to get the numbers to the other side of the equation. Here I'm adding 1, so I'll do the inverse, which is to subtract 1. Anything you do to the left side of the equation, do the right. I'm going to underscore every time I do a property of equality. Same thing to the left side as to the right. And I get 9x is equal to 22. But x is still not isolated. We want to get it by itself. We'll divide both sides. The very last thing I'm going to do is to divide. I'm not going to divide only if I have to get the x by itself. Otherwise, I'll do it some other means, subtracting or something else. I get 22 ninths. In this problem, I'm going to advocate using the box to try to isolate the variable. So this area model, negative 2 times 3 is a negative 6. And negative 2 times a negative x is a plus 2x. And on the left side, we have, again, for distributing. And distributing is the first thing I'm going to do when I'm trying to expand these and combine the like terms and so forth. So I get a negative, let's see, 3 times 1 is 3, and 3 times negative x is a negative 3x. So I can bring down the rest of the equation. X minus 6 plus 2x is equal to 2x plus 3 minus 3x. And we'll combine like terms. Combining like terms, we have an x and an x on the left-hand side. We don't combine on the left and the right. We're combining terms. So that means you do the one side of the equation or you do the other side of the equation. When we move the terms, that's another story. 2x minus 3x is a negative x. So we have 3 minus x. And now I want to move the small brother to the large. So I'm going to use the plus x to both sides because the negative x is smaller than 3x. So I'm going to move things to the left here. We're adding to both sides of the equation. Bring everything down. Notice how I lined up my x's. I'm not going to combine an x with a 6 because 6 doesn't have an x in it. They're not like terms. Here we'll add 6 to both sides of the equation. Anything you do to the left side, you do to the right. Every time I do a property of equality, I underscore it. So 4x is equal to 9. Now the x is still not isolated, so to do the inverse operation, we will divide both sides by 4. And you get x is equal to 9/4. Circle your answer. For our exit ticket, again, this is a problem with distribution on both sides of the equation. It's going to be similar to a test question that you might see. I'm using an area model to distribute. I do a negative 1 times x plus 5. And this is sometimes called the box. It's used, we use it sometimes in our school with quadratic equations. And so I'm starting you off by doing it with distribution. And this is an intervention I found useful with some kids who have a hard time seeing this. This is so that you don't drop the negative. Like a negative 4 times a negative 1 is a positive 4. And so that you don't mess that up. This is why we use this area model. Of negative x minus 5 is equal to, now I bring down my 2x and the stuff that I distributed, which was negative 4x plus 4. When we combine the like terms, here we have an x is on the right-hand side. There's nothing to combine on the left-hand side, so we're combining, and then we're going to move things around. When we combine a 2x minus 4x, you get a negative 2x plus 4. And now the smaller one of these is a negative 2x, so we'll move it to the left side by doing the inverse operation, which is to add, inverse of subtracting. Negative 2x is a multiplication, but I'm going to add the 2x to both sides of the equation. So I have x minus 5 is equal to 4. And then I want to do the inverse to get the x by itself. I'll add 5 to both sides of the equation, and I get x is equal to 9. And it was a little surprising, the number of people that struggle with this. All right, good luck and success.